Assalamu alaikum, dear students. Grade 12 are going to start, and in the grade 12, this lecture number 11, and this is our grade, and this is chapter number 13. This is chapter number 13, and the topic yesterday I told you group 7 elements, and I gave you some introduction about the halogens. Group number 7 elements, halogens. So these are the halogens. This is the group number 7A. So a few topics we discussed in the last lecture about the electron affinity, melting point, boiling point, bond enthalpies. So in the bond enthalpies, grade 12, it's a grade 12. Okay. In the bond enthalpies, if you see the 13.35 table, so you are seeing that fluorine bond enthalpy is small. Bond enthalpy of between the fluorine atom and fluorine atom is a smaller. But bond enthalpy between the chlorine and chlorine is a very high. Then bond enthalpy between the bromine smaller, less. And between iodine and iodine even smaller. It means that from chlorine to iodine, the bond enthalpy of the molecules will be decreased. From chlorine to iodine. And yesterday I told you in the previous lecture that electron affinity for the chlorine is higher than that of fluorine. So due to this structure changing, difference of structure, the bond enthalpy for the fluorine is smaller and fluorine is higher, then it is going to be decreased. Due to very small size of fluorine between atoms, the bond length is also very small. So there the repulsion between the non-bonding electrons is very large as compared by the halogen other atoms. This makes the fluorine atom molecule repel each other and helps for dissociation fluorine molecule into fluorine atom. So this is the reason for that why fluorine has a smaller value as compared to chlorine. For chlorine, bromine and iodine, this is now rationalized, decreases as we go down the group. Molecules stronger than fluorine and fluorine molecule, this is due to the possibility of existence of multiple bonding in halogen atoms if we go down the group. This is the reason. Now, bond enthalpies of the hydrogen halides. Hydrogen halide means hydrogen chloride, hydrogen fluoride, bromide, iodide, like this one. So if you see the 13.36 graph, bond enthalpies in kilojoules per mole, hydrogen fluoride has the highest bond enthalpy dissociation of the bond between the hydrogen and fluorine. You need high amount of energy. For the hydrogen and chloride, smaller and smaller. So, dear students, we done in grade 11 in the bonding, these depend upon difference of electronegativity, size of the halogen atom. So between the hydrogen and fluorine, the highest electronegativity. because the hydrogen is a 2.1 and fluorine is a 4, so it will be a 1.9 difference. Hydrogen chloride, chlorine is a 3 and hydrogen is only 0.9 difference. As you go, the difference decreases. So become a less polar. Polarity decreases as we go down the group for the hydrogen halide. So when the polarity decreases, the bond distance will be more between the hydrogen and halogen, so enthalpy will decrease. So you need less amount of energy to dissociate the bond. So this is the reason, and which is given also in your book. Attached to the hydrogen, and also there is a no lone pair electron on the hydrogen atom. Hydrogen is only one electron, no lone pair. As the halogen atom gets bigger from fluorine to iodine, size of the halogen atom is going to be bigger. So that's why the bonding pair gets more and more distant from the nucleus, I told you. The bonding pairs are going to be away, distant, away from each other. So due to this reason, the attractive is less. Attraction between the hydrogen and halogen will be less. That's why bond gets weaker. So bonds get weaker means less amount of energy is required with the bond between the hydrogen and halogen. So exactly what happens when the data there is nothing complicated happening in this case. So there is the one thing that this is the bromine and this is the halide ion. So there is a displacement. There is a displacement here. So we will get here bromide ion and hydrogen molecule. This is a displacement here. One example is given here in the 48th page. Now, strength of halogen as oxidizing agent. Fluorine molecule is highest oxidizing power. So then oxidizing power is going to be decreased. Oxidizing power. This oxidizing power. So if you see, if you are going to see the chemical reactions, I told you fluorine has the highest oxidizing power and iodine is the least one, and vice versa. Iodine has the highest reducing power and fluorine has the least one. A substance has tendency to accept one more electron is said to be oxidation. So oxidation is a loss of electron. Oxidation has a loss of electron, so which is a reducing agent. The substance which is oxidized is called reducing agent, and the substance which is reduced is called oxidizing agent. So fluorine has the most ability to gain electron. It has very smaller size, 7 electrons, so very high ability to attack electron here. So that's why it is among all the halogen, it is good oxidizing agent. The halogen, due to the high electron affinity value, already I told you, great tendency to accept electrons, so that is why they are strong oxidizing agents. Oxidizing property of halogens already I mentioned here. So it means that this is the halogen. It may be gaseous state, it may be liquid state, it may be solid state, because fluorine and chlorine is a gas, bromine is a liquid, and the iodine is a solid. So electron is going to be added here to make a halide ion. This is a halide ion in aqueous solution. So this is a 0 and -1. This is called a reduction. So in this case, I told you electron affinity, the amount of energy is released when the monovalent, by addition of one electron, if halogens get a one valent negative one, so the amount of energy is going to be released. This is called electron affinity. Above reaction is accompanied by release of energy. I told you this one, which is made up of many energy terms like heat of fusion, heat of vaporization. It has been seen that already I told you electron affinity of chlorine is higher than that of the fluorine, and oxidizing power is going to decrease as I move from fluorine to iodine. It's already written here. So fluorine is the strongest oxidizing agent and iodine is the weakest oxidizing agent. It means that fluorine can oxidize all the halogen. So fluorine can oxidize all the halogens. So this fluorine 0 and it's negative, there is a reduction. And this is the halide, maybe chloride, maybe bromide, maybe iodide, because it's a powerful oxidizing agent or strong oxidizing agent. So this is going to be oxidation. So this is the reduction in fluorine. The substance which reduces is called oxidizing agent, and substance which oxidizes is called a reducing agent. So fluorine can oxidize all halogens because it is the strongest oxidizing agent. So fluorine can oxidize chlorine, chlorine can oxidize bromine, bromine can oxidize iodine, iodine has got ability to oxidize other halogens, and fluorine can oxidize all. It is a powerful oxidizing agent according to equation you are seeing. Okay. Acidity. Acidity of hydrogen halides. In this topic, all the halogen acids in aqueous solution, they dissociate into hydronium ion. And halide ion. According to the Lorentz-Bronsted concept for acids and bases, the acid is a donor of proton and base is a acceptor. So this is an acid and this is a base. This is a acceptor of proton to make a hydronium ion, and this is a donor of proton to make a halide. So this is the general equation for this one. So if you compare the hydrogen halide, hydrogen fluoride is a weakest acid, means this is the less acidic than hydrogen chloride, less acidic than hydrogen bromide, and less acidic than hydrogen iodide. Means that hydrogen iodide is the strongest acid among all the hydrogen halides, and hydrogen fluoride is the weakest. So this is the weakest. Hydrogen fluoride is the weakest acid among all the halogen acids. The reason is that because of fluorine has a very weak, we can say smaller size, bond is strong between hydrogen and fluorine. So when you are going to dissociate, when you see the structure of hydrogen fluoride, so there the hydrogen is going to be in between fluorine and fluorine atoms. It's not going to be ionized easily in water. ionization of the hydrogen fluoride due to strong bond, hydrogen bonding is there. So due to present hydrogen bonding between the hydrogen and fluorine, the bond is strong, so it makes hindrance for ionization. As I am going to go down the group, this bond is weak and weak. That's why hydrogen iodide, the weakest bond, it can ionize very easily. So due to this reason, that hydrogen fluoride is the weakest acid and hydrogen iodide is the strongest acid. Written also here, the weakest acid is hydrogen fluoride due to the fact dissociation energy of the hydrogen fluoride bond is the highest. I will do strong bond, where the strong bond is here. So tendency for splitting of hydrogen and iodine and aqueous solution is very less. Now halide ion as a reducing agent, I told you. Halide ions. Fluorine molecule is strongest oxidizing agent and weakest reducing agent. Iodine molecule is the strongest reducing agent and weakest oxidizing, reverse. So here in this topic, the redox reaction between halide ions and concentrated sulfuric acid for the bromide. So bromide ions are going to be oxidized by the loss of 2 electrons. There is oxidation. By the loss of electron, oxidation. So the bromide ions reduces to sulfuric acid to make a sulfur dioxide gas. This is a sulfuric acid. Sulfuric acid and hydrogen ions are there. By the gaining 2 electrons, changing into sulfur dioxide gas and water. So dear students, sulfur have a positive 4 and sulfur positive 6. There is a reduction. There is a reduction. So if you add these two equations together, electrons of the reduction and oxidation are going to be cancelled here. So sulfuric acid plus 6 and 2 hydrogen ions plus 2 bromide ions in aqueous solution to give sulfur dioxide gas and bromine molecule plus 2 water molecules. So students, you see there is a reduction. There is reduction here and there is an oxidation. Bromide negative, then 0, this is oxidation. This reaction is a redox reaction. This reaction is called redox reaction because bromide ions are going to be oxidized and they reduce sulfuric acid to give us sulfur dioxide gas. And I told you that fluorine is the most oxidizing agent and least reducing agent. Iodine is the most reducing agent. Means if I put iodine here, the chemical reaction is different, which is given here. Because iodine is a more oxidizing, reducing agent than bromine. So please write this equation. Write this equation where? This is given in the book. Now, if you see for the iodine with iodide ions, when iodide ions going to be oxidized, oxidation of iodide ions. So this is strange, very strange is here. Iodide ions are much more stronger than bromide ions. They are much more reducing agent than that of the bromide ions. So they can oxidize concentrated sulfuric acid. The concentrated sulfuric acid is going to be reduced, but the chemical reaction is complicated. The reduction of sulfuric acid is much more complicated as we discussed before. The iodide ions first, there are points. There are points. In first step, sulfuric acid, positive 6 oxidation number, changes into sulfur dioxide gas. This is step number 1. Sulfuric acid changes into sulfur dioxide gas. Step number 1. So here the chemical reaction should not stop. Second step, this sulfur dioxide gas, these equations are not given in the book, please write down, changes into sulfur solid. Second change. First reduction, second reduction. Third, this sulfur 0 in presence of acid hydrogen ions to make a hydrogen sulfide. So hydrogen sulfide negative, it means that sulfur 0 changes into negative 2. Sulfur 0 changes into negative 2. So dear students, if I'm going to write the whole equation now, 2 iodide in aqueous to give iodine plus 2 electrons, this oxidation, and sulfuric acid plus 8 hydrogen ions to give the iodine, already iodine. You will get hydrogen sulfide plus 4 water molecules. So this is a last step which is given here. Last step where sulfuric acid changes into a sulfide hydrogen. This is the last one. If you add these 3 steps, you will get this. So now if you add these all, this is sulfuric acid in aqueous hydrogen ion acidic media plus 2 iodide to give a hydrogen sulfide plus iodine and plus 4 water molecules. So students, here sulfuric acid is a plus 6. In hydrogen sulfide there are minus 2. So plus 6 and minus 2, last step. Plus 6 changes to minus 2 if you add all these. And this iodide negative changes into 0. That is why this is going to be reduced and this is going to be oxidized. So iodine itself oxidizes, it's a reducing agent. Sulfuric acid itself reduces, so it's the oxidizing agent. So this is a redox reaction. So because of iodide, ions have a high tendency to oxidize, to make a reducing agent as compared to bromide ions. That's why you will get a different products, and the last product is that sulfur 6 changes into sulfur negative 2 in the form of hydrogen sulfide. Now fluoride do not reduce sulfuric acid because they are weak. Fluorides and chlorides do not reduce sulfuric acid. Only two they are given. Explanation. When a halide ions acts as a reducing agent, it gives electron to something else. This means that halide ion itself is double loss of electron. Yes, negative to zero, there is oxidation, there is loss of electron. A bigger the halide ion, bigger means iodide, the bigger ion, biggest ion. The outer electron form the molecule, and the more they are screened from it, and inner electrons therefore gets easier to halide ion lose electrons as we go down the group, because there is the less attraction between the outer electrons of the nucleus and the bound iodide ions. Bigger ions, their outer electron is not very attracted towards the nucleus, so it is loosely, so that's why it can lose electron very easily, so there is loss of electron technical oxidation. As we go down the group, ionic size is going to be increased. That's why iodide ions are the highest, largest ionic size. They are strongest reducing agents. Fluoride ions and chloride ions do not reduce the sulfuric acid. Students, there are quick quizzes. Hydroiodic acid is the strongest, and hydrogen fluoridic acid, already I told you example. Hydrogen bonding is stronger. Yes, there is. This is also done, I think, in your grade 11. I'm giving you hint and you write yourself. Reference to hydrogen bonding. Hydrogen bonding is a special kind of bond which is between the smallest size of hydrogen and between fluorine, oxygen and nitrogen. In the hydrogen fluoride, the bond is strongest due to the highest electronegativity between hydrogen and fluorine. And next one is the water. The hydrogen bond between water and hydrogen is not much stronger than that of the hydrogen fluoride, because the electronegativity of the oxygen is 3.5, so it gets less difference as compared to hydrogen fluoride, because the fluorine has a 4 value of electronegativity. But more the difference, more the polarity, hydrogen bond will be stronger. So hydrogen bond between hydrogen and fluorine is stronger than that of water. But the question is that, but why the melting and boiling point of water is greater than that of the hydrogen and fluorine? Hydrogen fluoride is a volatile liquid, but water is less volatile. Again, I am repeating this. Although hydrogen fluoride has a strong hydrogen bonding than water, but why water liquid has a higher boiling point, melting point than the hydrogen fluoride? Reason. This is given in the grade 11 you done in the liquid chapter, but now I am telling you that the hydrogen fluoride molecule form only one hydrogen bond between each other. There is a formation of one hydrogen bond between hydrogen fluoride and hydrogen fluoride to form a zigzag. But the hydrogen bond between water and water, there are many due to the 2 lone pair electrons of oxygen. 2 lone pair of electrons are present in oxygen. This water form more hydrogen bonding. with each other as compared hydrogen fluoride. So water forms more hydrogen bonding. That is why the boiling point and melting point is going to be high. More formation of the hydrogen bonding as compared to hydrogen fluoride. So this is answer for this. Acidic character of the halide 7A increases on descending order. Yes, acidic character I will because size of the halide ions are going to be increased, so they can easily dissociate in water. You have tried the question. So students write these answers, and we finish this chapter here. The chapter is going to be finished, complete. For the big chapter, and you go through this, solve all exercises questions and objective questions, and solve also federal board question papers you can download from the net. This chapter is going to be end. Each and everything you have to complete, because this chapter is not repeated, because there are many other chapters and very difficult. Other chapters, transition element different from here, so there is no repetition. That's why you have to complete in all respect. Thank you very much.